afternoon to all of my students. I am Dr. Srirupa Banerjee, Department of Chemistry, Bethune College. Today, I will discuss on Grignard reagent. Organometallic compounds are compounds where at least one carbon metal bond is present. There are many types of organometallic compounds. Many metal can form carbon-metal bond and generates organometallic compounds. Among the metals, lithium, magnesium, copper, zinc are widely used. Since the beginning of 19th century, many other organometallic compounds are also known where silicon, tin, cadmium, etc. are used as a metal. In this connection, it has to be mentioned that all carbon metal bonds are covalent in nature. Here, in this case, we will focus our discussion on organomagnesium compounds, which is known as Grignard reagent. Victor Grignard was an organic chemist who reported organomagnesium compound first where carbon magnesium covalent bond is present in 1899 and awarded Nobel Prize in 1912. Grignard reagent is a widely used reagent for the synthesis of different functional groups containing organic molecules and also used as a reagent for higher homologation of carbon. The reagent is very much relevant till today. In this slide, this is the structure of RMGX where R is an alkyl group, magnesium used here is as a metal and X is halogen. And its versatile application is really relevant till today. Preparation of organomagnesium compound. Here we will discuss about the preparation of organomagnesium compound, that is Grignard reagent. Alkyl halide with magnesium we can generate organomagnesium compound, that is RMGX, which is known as Grignard reagent. The common solvent is diethyl ether. For preparation of vinyl magnesium bromide, we use THF, tetrahydrofuran. This is a very important observation in this case, that is we see ampullum here, which is known as reverse polarity. In alkyl halide, polarity of alkyl group is formal charge of alkyl group is positive here as shown in this slide, whereas in RMGX, that is in case of Grignard reagent, alkyl group is negatively charged. Here we see the reversal of polarity, that is ampullum. This is a very important observation for the preparation of Grignard reagent. Here X is sorry, here X is preferably iodine, bromine or chlorine, whereas R is preferably 1 degree greater than 2 degree greater than 3 degree because 3 degree suffers from elimination. Again, preparation of Grignard reagent becomes difficult with increasing number of carbon in alkyl group, that is methyl is preferable over ethyl, and ethyl is preferable over propyl, and so on. During the preparation of organomagnesium compound, that is Grignard reagent, we have to take some precautions. Number 1. Solvent should be perfectly dry or anhydrous and of course alcohol free, because after taking hydrogen from water or alcohol, Grignard reagent forms alkene. Here, this RMDX, that is Grignard reagent, can take up this proton of water or this proton of alcohol to form alkene. So, solvent should be perfectly dry. Number 2. Reaction should be carried out under nitrogen or argon atmosphere, because in the presence of oxygen it forms peroxo type of compound which undergoes following types of reaction to form this, this type of compound. So this further hydrolyzed to form alcohol further in presence of water. In course of preparation of Grignard reagent, magnesium should be entirely oxide free, because due to the coating of magnesium oxide over magnesium will cause difficulties, since reaction occurs from surface area of the magnesium. Now, method 2. Preparation of magnesium organomagnesium compound, that is Grignard reagent, by transfer of magnesium. A number of Grignard reagents simply by exchanging the position of magnesium and halogen, we can prepare different type of organomagnesium compound. That is, here is an example where we can see that ArMgCl is prepared by transferring magnesium from IPrMgCl, and then type 3. Number of allyl and benzyl ethers and thioethers are reported to yield Grignard reagent with magnesium as shown here. Now, I want to mention that what is Reiki. Reiki is a highly reactive metal powder. Now, another type of preparation. The preparation of Grignard reagent, which is free from halide impurities, was achieved using dialkyl mercury with magnesium as shown here. Now, the structure of organomagnesium compound, that is Grignard reagent. Grignard reagent remains in complex structure with many species in equilibrium known as sling equilibrium. This can be an important topic and we can discuss more in other lectures. Now, this is the type where we see the Grignard reagents are remain this type of formations. The extension of association depends on the concentration and is extensive above zero point 0.3 molar. In solution, Grignard reagent is coordinated with ether molecule. This is the monomeric structure of Grignard reagent, whereas this is the dimeric form of Grignard reagent. This is about the structure of Grignard reagent. Property of organomagnesium compound. That is for property of Grignard reagent. Grignard reagent acts as a base. Grignard reagent acts as a base and produce an alkane after abstracting proton from any compound which contains active hydrogen, as shown earlier. In case of water and alcohol, we see that. Now, if this is considered as ZH and Z is all these groups, then we can produce alkane, or Grignard reagent can produce alkane uh, after treating with these type of compounds. When Grignard reagent acts as a base, we can use this property for deuterium incorporation, and this is the reaction where we can get deuterated alkane. And again, for synthesis of acetylene magnesium bromide, we can use Grignard reagent where it acts as a base to form acetylene magnesium bromide like this. Now, another property of Grignard reagent using as a base we can see here. Determination of presence of active hydrogen in any compound, which is known as Zeri-Grignard active hydrogen determination. We can use this and we can estimate or determine the active hydrogen in the compound. From the used amount of Grignard reagent, we can determine the presence of active hydrogen in any compound. Now, Grignard reagent as a nucleophile. Grignard reagent acts as a nucleophile and used for preparation of different type of compounds containing different functional groups. We start with alcohols. Alcohols, we know that there are different type of alcohols, 1 degree, 2 degree, 3 degree, and in case of 1 degree alcohol, now we will discuss about 1 degree alcohol. 1 degree alcohol can be prepared by using Grignard reagent, and this is the particular case of 1 degree alcohol with zero carbon homologation. That is in RMTX. The from RMTX we can get R, that is alkyl group, and we can form ROH from this compound after hydrolysis. This is discussed previously. In the presence of oxygen, this is peroxo compound. Another molecule of Grignard reagent react with this peroxide and form ROMDX, which after workup we can ended up with alcohol. Now, 1 degree alcohol plus 1 carbon homologation. That is, for RMGX, we want to prepare RCH2OH. To prepare this is the backward reaction shown over here, this R minus, as we discussed earlier, that is R minus in the RMGX. This is for umpolam. We can generate R minus from RMGX, and this is CH2OH plus. We can think about this alcohol RCH2OH is as a R minus and CH2OH plus. Now R minus comes from RMGX, and CH2OH we can think about this from HCHO, that is formaldehyde. Now this is the forward reaction. When Grignard reagent react with formaldehyde in presence of ether as a solvent, it forms RCH2OH index, which upon hydrolysis form RCH2OH, which is one carbon homologation of primary alcohol. Now, this reaction proceeds via six-membered transition state, which is shown here, where 1 mole of Grignard reagent acts as a Lewis acid and another mole of Grignard reagent acts as a carbanion. That is, this is the R group, which is R minus group, which transfers over here, and this RMGX acts as a carbanion, and via this six-member transition state, it will form this RCH2OMGX. Here, this is a, here need a correction. That is here, this bond will not be, it must not be here. This is wrong. It have to be correct. Now, this formation of this RCH2OMGX will produce RCH2OH from RMGX and formaldehyde. Mechanism supports involvement of only 1 mole of Grignard reagent for this reaction, as after the reaction we get back 1 mole of RMGX. Now we can use Grignard reagent as a nucleophile. We know that, and we can synthesize 1 degree alcohol plus 2 carbon homologation starting using RMGX, that is Grignard reagent. Now if you want to synthesize RCH2CH2OH using RMGX, we can think that R minus will come from RMGX, and another part, which is CH2CH2OH plus, will come from this epoxide. Now this RCH2CH2OH can be prepared using this epoxide and RMGX in presence of ether, and after hydrolysis 2 carbon homologation of ROH will generate. This is a real example when pH beer and this epoxide is used, and magnesium trihydrofuran is used as a reagent, and after hydrolysis with H3O plus we will generate pH CH2CH2OH. This is incorrect. It must be pH CH2CH2OH. Now, for synthesis of 3 carbon homologation, that is RCH2CH2OH, we use RMGX and this compound using THF, and after hydrolysis we will get this product. This This is all about 1 degree alcohols. Now we can synthesize 2 degree alcohol also using Grignard reagent. That is, we can synthesize R2CHOH from RMGX using RMGX. This R minus comes from Grignard reagent and CHROH plus will come from RCHO. This is our forward reaction, and sometimes NH4Cl is used in this case of reaction to maintain the pH. And this is an example where we use Grignard reagent to synthesize 2 degree alcohol. When ethyl formate is treated with Grignard reagent, that is 2 degree alcohol are formed. 2 equivalent of RMGX required here. This is a process for synthesis of 2 degree alcohol containing 2 similar alkyl groups. This is our backward reaction as shown earlier, and from this we can use RMGX, and this is wrong structure, wrong mechanism. This has been inverted, so I am skipping this one. You can see this and you will understand the forward reaction. This is the ethyl formate and this is Grignard reagent, and this is all about the forward reaction. This is just inverted. If you see carefully, you will observe the actual reaction. Now 3 degree alcohols. When ketones are treated with Grignard reagent, 3 degree alcohols are formed. That is, R3COH will form using RMGX. Now R minus will come from RMGX and CR2OH plus will come from ketone. Now this is the forward reaction, and this is an example where we synthesize 3 degree alcohol using RMGX here. When ethyl chloroformate is treated with Grignard reagent, 3 degree alcohols are also formed. We can treat ketone with RMGX to form 3 degree alcohol. And if you want to go back more backward reaction, we can consider this one. This ketone can be generated from like this, and this RCO2 minus RCO2 will generated from this one, and this COOET will comes from ethyl chloroformate, and this R minus will come from RMGX. That is, if you want to start from ketone like previous case, we can end it up with this 3 degree alcohol. Again, if we want to generate 3 degree alcohol, we can use ethyl chloroformate also with RMGX to generate 3 degree alcohol. This is our forward reaction and an example where we can synthesize a 3 degree alcohol. Now, reaction with esters give 3 degree alcohol with 2 similar alkyl groups. This is again an example where 2 R groups, that is this R and this R, comes from this RMGX, that is from this Grignard reagent, and this R minus comes from this ester group, and we will get a 3 degree alcohol over here. Now, in the reaction mechanism, this will form, which we can denote as A. Mechanism for this reaction with ester involve this intermediate A, which further reacts to give alcohol. However, if this reaction is quenched at this stage, then there is a possibility to get back ketone. That is, if we quench this reaction, this will form OH and this will again form OH. So, from these two OH, we will get ketone. This is also possible since it is more reactive than ester. Because we can think that this is more reactive than ester. So, however, under general condition, that is during the direct addition, we add substrate to the Grignard reagent. So, there is a large excess of Grignard reagent which is very reactive and so obviously less selective. So, it reacts both ester and A. But if we add Grignard reagent to ester, that then there is a possibility to stop reaction at A. Since the more reactive ester is in excess, this process is known as inverse addition. So, for synthesis of ketone from an ester using Grignard reagent, we follow inverse addition procedure. Now, reaction with diethyl carbonate give 3-degree alcohols with 3 similar alkyl group. That is, if we want to generate this 3-degree alcohol with same R group, we will prefer to use this diethyl carbonate and RMGBr. This will produce the similar R group containing 3-degree alcohol. This is a representative reaction, possible backward reaction from which we can produce 3-degree alcohol. That is, it can be done from ketone using 1 mole PHMGBr. We can use ester using 2 mole PHMGBr, and we can use diethyl carbonate using 3 mole of PHBr. Now, Grignard reagent can also used as a nucleophile for the synthesis of carbonyl compounds. At first, we will discuss about aldehyde. Here is the backward reaction. Aldehyde RCHO. This is known as acetal, and this can come. We can think about R minus from RMGX, and this is CH plus OET whole 2 and come from CH OET whole 3. Again, RCHO can be think as a R minus, which comes from RMGX, and CHO plus, which comes from ethyl formate. This is the forward reaction where CHOET whole 3 and RMGX is used and to produce this acetal, and after hydrolysis we will end it up with aldehyde RCHO. Now the synthesis of ketone. This must be R2 suffix to R2CO, and this is a backward reaction. Now R2, and we can use R as R1 and R2. Now R1 COR2, this is a ketone, and we can consider this backward reaction as imine, and this imine can generate from RCN. This is the and this R minus this R1 can come from R1 MGX, and this R2 comes from R2CN. Now the forward reaction R2Cl plus R1MgX, which can form this imine, which after hydrolysis with H3O plus we will we can synthesize ketone R1R2CO. This is the best method of synthesis of ketone using RMGX. There are several methods, but I have shown it here because this is the most important and most effective one. Now, the carboxylic acid. Carboxylic acid also we can synthesize carboxylic acid using Grignard reagent. And similarly, this R group comes from RMGX and this CO2 group comes from carbon dioxide. This is a very well-known example and this is very important reaction. Um, we will discuss it later on when we use alkyl lithium compound. This is a major difference when we react with RLi with CO2, we will end up with ketone, and in this case, when RMDX is used, we can synthesize our CO2H using, that is carboxylic acid groups, using Grignard reagent. Now the ester groups. Ester can be prepared by inverse addition of Grignard reagent to the ethyl chloroformate or diethyl carbonate as discussed earlier. If inverse addition is not performed, reaction does not stop here. At this stage of ester, further reaction takes place and ester forms ketone first and then final product becomes 3-degree alcohol. Alkyl cyanide also prepared from Grignard reagent using RMGX and ClCN, that is interhalogen compound type of compound ClCN and cyanogen gas. Amine can also be prepared using RMDX, that is using RMDX and NH2Cl we can generate amine here. Ether. Ether can also be prepared using Grignard reagent as a nucleophile, and this is the example where we can synthesize this type of ether. R is OCH2CH3. This CH2CH3 comes from this type of ether, this from this one actually, and this is the Grignard reagent we use to generate this one. And alkane can also be used. We discussed it earlier even. We can prepare alkane using Rx and R prime MgX, which can produce R prime, which is known as alkane. Now the abnormal behavior of Grignard reagent. Hindered ketones undergo reduction with Grignard reagent which have beta hydrogen. We observe reduction of ketone to 2-degree alcohol, which is abnormal behavior. This is isopropyl magnesium bromide and this is diisopropyl ketone. That is, this is a ketone, and normally from ketone we will get 3-degree alcohol, but in this particular case we will get 2-degree alcohol and via this transition state. This has a beta hydrogen over here, sorry. This has a beta hydrogen over here, and this hydrogen will attack in this carbonyl compound, and this via this 6-member transition state, this diisopropyl OMG-Br will produce, and this hydrogen is this comes over here, and an alkene will produce from this side of the reaction, this side of this six-member transition state, this alkene will generate and diisopropyl OMGBr will produce from this side of the six-member transition state, and after hydrolysis we will get the 2-degree alcohol. Another abnormal behavior of Grignard reagent was observed when phenyl magnesium bromide reacts with phenyl PHCHO, that is benzaldehyde. At first, benzaldehyde forms 2-degree alcohol which further reacts with another molecule of PHCHO to yield ketone and 1-degree alcohol. The reaction goes via this 6-member transition state, and from this we will get PHC OMGBr, PHCHCOMGBr, and this here is a mistake. This must be H. From this is H, this is H, and this is again H. Now, this after on hydrolysis we will get PHCH2OH. Now, ketones having alpha hydrogen sometimes forms enolate instead of normal reaction to carbonyl center. That is, when this hydrogen is very much active or acidic, it can react with RMGX. That is, if we use CH3MGBr, it can react with CH3 and form methane, and enolate will form instead of normal reaction in this carbonyl compound. Magnesium is not so hard like lithium, which where lithium always gives 1,2 addition, and not so soft like copper. That is, copper always gives 1,4 addition. With alpha beta unsaturated aldehyde, Grignard reagent undergoes facile addition to CO. That is 1,2 addition. Here is the example. If we react with this ethyl magnesium halide, we will end up with 1,2 addition over here. But with alpha beta unsaturated ketone, there is a competition between 1,2 and 1,4 addition with predominating 1,2 addition. Actually, in this case, 1,2 addition product is almost total conversion of from alpha beta unsaturated ketone when you use Grignard reagent. This is a major one. This is very minor, but this is major one. 1,2 addition predominating under normal condition. But in presence of copper 1 catalyst, we will observe 1,4 addition as a major product. But in absence of copper 1, this is predominating, very much predominating, and sometimes very little amount of 1,4 addition product will observe. In this connection, Grignard reagent is used since 19th century. We know this, but Grignard reagent is relevant till today as discussed in the first slide. The advanced study with Grignard reagent is carried out during the course of many type of reaction. The very important type of reaction is CC coupling. And if we use RMGX and RX in presence of palladium 0 and nickel 2 or nickel 2 in presence of any ligand, CC coupling will observe, which is known as Kumada coupling. The Kumada coupling was the first palladium or nickel catalyzed cross coupling reaction developed in 1972. The coupling of Grignard reagent with alkyl, vinyl or aryl halide under nickel catalysis provides an economic transformation, but the reaction is limited to allyl partners that do not react with organomagnesium compound. One example is in the industrial scale production of styrene derivatives, and the Kumara coupling is the method of choice for the low cost synthesis of unsymmetrical bioaryls. The advantage of this reaction is the direct coupling of Grignard reagent, which avoids additional reaction steps such as the conversion of Grignard reagents to zinc compound for the starting material and in the which is in the negation coupling. This palladium 0 with ligand oxidative addition with allyl halide. Palladium 0 will enhance its oxidation number to 2. Now it is palladium 2, and with RMGX transmetallation takes place. Transmetallation takes place, and this ligand, this X will replaced by R. And after the formation of this palladium 2 complex, trans-cis isomerization will take place, replacing the ligand and R group. And after the reductive elimination, this CC coupling occurs, that is, it forms ARR biaryl compound, and we get back the palladium 0, which is catalyst. And this is the whole reaction mechanism: oxidative addition, transmetallation, trans-cis isomerization, and reductive elimination. That's all about the Kumada coupling, and this is a very advanced study of Grignard reagent. And with this, I want to conclude my discussion, and thank you for your patience hearing. Thank you.